Hello and welcome to this exciting video and more concept. So in this video, we'll just look at one specific part, which is the percentage yield. I've got a specific question I want to solve, but for us to get there, I want us to just look at some formulas that will be very helpful in this lesson today. So we have this formula, the first one here, very important, and it's the major formula because you can't work out without finding moles, okay? So that's why sometimes we call this as the Moore concept, okay? Because it falls on the topic called stoic geometry, okay? So you have the Moore is equal to M over mm. Now what is M? M, that is the mass, okay? And then the mm, that is the molar mass, and the units, it's grams, and the units for molar mass, it is simply grams per mole. So the molar mass, sometimes it's known as the relative formula mass or relative particle mass, okay, depending on how the people who wrote the book are using saying it, okay. But I just like to stick to the molar mass and grams per mole. So I made a certain video, just check out this video here, where I was calculating different molar masses of things so that you get acquainted. So we also have the concentration is equal to mole over volume. The mole should be, this is the units for the mole. The volume should always be in cubic decimeter, okay? And also here, you can also work around this ratio here. That for all gases that are at room temperature and pressure, 1 mole of any gas which is at room temperature and pressure will always be equal to 24 cubic decimeters. Okay, very high yield information here that you need to know. Also, Avogadro's constant comes up, it shows up sometimes, okay? You need to know that 1 mole is equal. So meaning that you have to convert each and everything to moles, okay? You see, you're using moles almost on everything, okay? You can't work around without converting things to the moles, okay? Now, the topic of interest that we want to do today is percentage yield. So percentage yield is equal to actual yield over theoretical yield times 100, right? So this is 100%. Let me just write it there, okay? 100%, okay? So we have a question that I want us to do, okay? We'll go through the question together. So the question says that ethanoate, given by this formula, okay? So that's the question there that we're doing from that past paper. Ethanoate, CH3CO2, C2H5 can be prepared from ethanol and ethanoic acid. Write the chemical equation for the reaction, okay? Calculate the theoretical yield, which can, okay, so here I made a mistake. Calculate the theoretical yield for ethyl ethanoate, okay, which can be obtained from 23 grams of ethanol, okay? You can check out the question to read the question properly. If 33 grams of ethyl ethanoate is produced, calculate the percentage yield. Then the last question says, to which homologous series does ethyl ethanoate belong to? Okay, so I love this question for the fact that it combines two topics together, which is the Moore concept and the organic chemistry, which are two topics which are very, very crucial in chemistry, but this question combines everything together. So let's deal with it one by one. So write the chemical equation for the reaction. Which reaction? We're trying to prepare ethyl ethanoate. It can be prepared from ethanol and ethanoic acid. So these two are what? Our reactants. Okay, let's head over to the questions. Okay, so here we are. So question A simply wants us to react what? Ethanol. First, I'll write them in their names. You don't have to do this in the exam. Ethanol plus ethanoic acid. Okay, you don't have to do this, what I'm doing, just for the sake of illustration. So is equal to ethyl ethanoate. Okay, there's always water given out at the end. Okay, there's always a water given out at the end. Okay, so now let's write it now in symbols. Let's see if I can use a different ink. I like to, okay, so CH. So I made a video again. If you don't know how to write these things, the chemical formulas, the molecular formulas, please just search for a video on my channel. Okay, there's a video I made for organic chemistry. Okay, I made 2 videos. There's part 1, part 2, and then part 3, part 4. Okay, so there are 4 videos there. Okay, so ethanol is written like this: C2H5OH. That's how you write ethanol. Okay, plus now ethanoic acid. Okay, it is written like this: CH3COOH. Now, lucky enough, the question here already gave us ethyl ethanoate. Okay, so for ethyl ethanoate is just CH3CO2C2H5. Okay, so it is CH3CO2 C2H5. Okay, we know that we will get water. This is a condensation type of reaction where a water molecule is given out. Okay, so write the chemical equation, and here we are. Okay, so these you can put them in aqueous. Essentially everything here can be in aqueous. Water can put it in liquid. Okay, so this is the formula. It says write the balanced equation. Okay, so if we check here, these equations, the goodness that they're always balanced, right? Okay, just for the sake of clarity, carbon 2, 3, 4 carbon atoms. 1, 2, 3, 4 carbon atoms, balanced. Hydrogen 5, 6, 7, 8, 9, 10. Hydrogen 3, 8, 9, 10. Oxygen 1, 3. Oxygen 2, 1, 3. So everything here is balanced, right? Okay, and we are good. So question 1A, this is all that you need to do here. Okay, see, so this is ethanol plus, so it's just 1 mic. Okay, you don't need to go round about doing unnecessary things. Okay, so let's go to question B. Okay, so this is now interesting. Now write the chemical equation. Done. Calculate the theoretical yield for ethyl ethanoate, which has been formed. Ethyl ethanoate, okay, which can be obtained from 23 grams. So this is 23 grams of what? Ethanol. Okay, 23 grams of ethanol. So let's do this. Okay, so we have ethanol. We are told ethanol is actually 23 grams. And I want to find how many grams. Okay, so we call this theoretical yield. Now, what is this theoretical yield that we're talking about? It is the amount in grams of the product that you wish to get from the calculation. Okay, from the what? From the calculation. So we're going to find the mass here in grams simply from this. Okay, so like I said, you can't do this without moles. So everything needs to be in moles under more concept. I wish I can just go through the whole topic, but time won't allow. So we'll do it in parts. Okay, so we need moles. We don't need grams. Okay, we need to take them to moles before we can find anything else. Okay, so we want to find the theoretical yield. In other words, we want to find the mass of this product, which is what? Ethyl ethanoate. So what you are going to do, work in moles. Okay, you're going to say mole is equal to mass over molar mass. The mass here you are given 23 grams. Now the molar mass here, now this is where, now please pay attention here. Like I said, I did a video on the molar masses. You're going to get this which is C2H5OH. So here you're finding the mass for this whole compound. It's called the molar. It's called the molar mass. Right? Okay, the molar mass. Okay, the molar mass. So we are trying to find okay, molar mass for this. So you have you are going to list the elements here. So you have carbon. How many carbon are here? There are 2. You multiply by their mass. Check on the periodic table. The mass number of carbon is actually what? 12. Hydrogen, how many of? 5, 6. So H, there are 6. Multiply by the mass. The mass is just 1. Oxygen, you only have 1 there. So oxygen, you only have 1. What's the mass of oxygen? 16. 2 times 12, you get 24. 6 by 1, you get 6. Here you get 16. And what do you do now? After this, you need to simply add 16 plus 6 plus 24, and you are good to go. So the mass number, you just list, you find the masses of all the elements that you are given. Okay, so 16 plus 12 plus 6. Okay, so here you happen to get 34. What are the units? I said grams per mole. Okay, just write it here, 34 grams per mole. Now, what was I doing? You are counting the number here. These are the number of atoms. Okay, I hope I'm not confusing you. So you look at this. This 2 tells you there are 2 carbons here. That's why I wrote it here. Times the mass of carbon is what? 12. You check where? On the periodic table. You get 24. Hydrogen, there are how many? This tells you there are 5 plus 1, 6. The mass is 6. This is 1, so which is 6. Oxygen is just 1. Okay, so you get 34 grams per mole. So you write it here, 34 grams per mole. So you need to find the mole. Okay, you can't do nothing. You can't do anything. Okay, you can't do anything without the mole. So you say 23 divided by 34. And there you have 0.6 7. I can end at 7 5. Okay, just 3. So these are the moles now. So we've converted the moles of this ethanol to this. Now why do we need the moles? So that we can do what we call the mole ratio. Okay, so quickly here you got to do what we call mole ratio. So the beginning of these questions are mostly the same. First thing, in fact, the first thing should be here. Getting a balanced equation first. Okay, getting a balanced equation first. Then mole ratio. Mole ratio, now you compare. You've been given 23 grams for what? For ethanol. And you're finding the mass for this guy, which is called the theoretical. So you compare these two now. Okay, you are going to do mole ratio C2H5, which is ethanol. You compare it to CH3, CO2, C2H5, which is what now? Ethyl ethanoate. So now here you're going to look at, did I balance the equation with any numbers here? So here, if there's no number, it means here it's a 1. Okay, and we call these coefficients. Okay, simply means that that one there, it's a what? A 1. This one is 1 here. Here also it means it's 1. We didn't put any number. We find out the equation was already balanced. So you just 1 1. Okay. So here, what have I written here? It's the coefficient. Okay, the coefficient, sorry. And then the next here, what you write are the moles. The moles for C2H5 we calculated 0.675 mole. Here we don't know, we put x. Okay, then we cross multiply 1 by x, that will give us x. So we're now finding the moles for CH3CO2 C2H5, which will just be 1 multiplied by 0.675, okay, more, and eventually this will just be 0.675 moles, okay. So now these moles here, now what have we discovered? Now here we've discovered that actually even this compound has the exact same moles as in C2H5, okay. And the reason is simple, because you have one more here, so it's the same, right? So here the mole, you can say that the mole for this guy from the mole ratio is just 0.675 more. Okay, so now we can now find the mass, okay? You can now find the mass. So each time you are given a mole of something, you can easily find the mass, okay? And the mass, we are going to just change the substitution formula to this. Let me show you how that can be done. So mole is equal to mass over molar mass. Now if you're looking for mass, you divide by 1 here, cross multiply. So mass will be equal to what? Mole times molar mass. So the mole, what are we finding now? It is for this ethyl ethanoate, okay? This ethyl ethanoate. So the ethyl ethanoate. So it has the moles same as this. We just calculated that. 0.675, okay? Moles multiplied by the molar mass. Molar mass now, molar mass for what? We're finding this. So CH3CO2, let's find the molar mass quickly. So C, let me just use a different ink. So you have C, H3, CO2, C2H5. So you count, you start with carbon, okay? So carbon, how many carbons are here? 1, 2, 3, 4. So why am I counting this twice? Because of the 2 here. So 2, 3, 4. So 4 multiplied by their mass number is 12. Okay. H, how many H? 3 plus 5. That's 8. 8. What's the mass of hydrogen? 1. Then oxygen, 2. The mass is 16. Then you find the totals, then you are going to add them here. Okay, let's find the totals first. Then we are going to add. Okay, so 4 by 12, that is 48. This will give us 8. This will give us 32. Then we add 48 plus 8 plus 32. You get 88 grams per mole. So this is the molar mass, okay? So it's going to be 88 grams per mole. Okay, so now you just multiply 88 by 0.675 and you get 59.4 grams. So these are grams. So you say therefore the theoretical yield of CH3, CO2, CH2H5 is basically just 59.4 grams. Okay, so now this theoretical yield is just the the mass that you get before doing the reaction. So this is done before the reaction, right? Okay. So before the reaction, you find that if you get 23 grams of this, it should give you 59. But that's not always the case, okay? This is just theoretically. Theoretical means you have not done the experiment yet. Here you're just assuming, okay, if I react this and this, if I get 23 grams of this, it should give me at least 59.4 grams, okay? So here the mass is just 59.4 grams. And we're done with the question B. We now need to answer question C. Question C says if 33 grams, so this 33 grams now of ethyl ethanol is produced, this was now after the experiment is done. After you do the experiment, now you find that you get 33 grams. So this is what you call the actual yield now. What you actually get, not from the formula. This is now after the experiment, after you react the two substances, you are actually getting this. So if the 3 grams of ethyl ethanol is produced, calculate the percentage yield. Okay, percentage yield. So the formula is here. Percentage yield is equal to actual yield over theoretical yield times 100%. Let's see how we can do that one. Okay, so here now we're told that the 3 grams are produced. And from the theory, we calculated what? 59.4 grams. But in practical, you get this. So the question wants you now to find the percentage yield. You say percentage yield is equal to actual yield over theoretical yield times what? 100%. So the actual yield is what you get from the experiment at 3 grams. The percentage yield, the theoretical yield we've calculated 59.4 grams times what? 100%. Okay, now we just need to find the answer there. We just divide 33 divided by 59.4. Okay, then times 100. So here you happen to get 55.6. Or you can say 55.56. Okay, because the actual answer is actually 55.55555. So to round it off, we just say 55.56%. Okay, so this is your percentage yield. Okay, that's your percentage yield for this question. Okay, the last question simply says, to which homologous series does ethyl ethanol belong? Okay, so the homologous series is it's an ester. Okay, it belongs to what we call esters. Okay, so like I said, I can't teach everything in one video. I'll have to make another video. This is a combination of two topics. You have more concept and organic chemistry. Okay, so please, if you have any questions, leave it on the comment section. Those that would like to be part of our tuition center, just contact me on my number 0974 656239. Have a blessed day.